This video is on the solution of AP Calculus AB 2024 exam FRQ number 1. This is calc active, so let's get started. Okay, so this one says that question 1 says about there's a table where C of t, which indicates degrees Celsius, and T, which is in minutes, is given to us, and this is the temperature of a coffee in a cup. At time t minutes is modeled by a decreasing differentiable function c, where c is measured in degrees Celsius. So from 0 to 12, selected values of c are given in the table. Approximate c prime 5 using the average rate of change of c over the interval of 3 to 7. Show the work that leads to your answer includes units of measure. So we just have to find the AROC in this case, and AROC is to be found at 5, which is somewhere over here, obviously in between, using the points 3 and 7. So the AROC is going to be C of 7 minus C of 3 over 7 minus 3. All right. So this AROC is approximated as C prime 5. And this is going to look like 69, I believe. 69 minus 85 over 4. So let me just take my calculator here. 69 minus 85 over 4 is negative 4. Units are important, guys. So the units are going to be degrees Celsius per minute. Degrees Celsius per minute. So degree Celsius per minute. That is going to be the unit of this answer. The next one talks about Riemann sum. So you have to use a left-hand Riemann sum with 3 subintervals indicated by the data to approximate this entire thing. And then we need to interpret what is the meaning of this thing. All right, so let's do the Riemann sum over here. So 0 to 12 of C of t dt. That's going to be we need to do that in 3 subintervals, which means that the first interval is going to be 0 to 3. Since it's a left-hand Riemann sum, that's why I'm starting, from 0 on the left hand. This is 1, and this is 2, and this is 3. Okay, so I'm interested in the area, of course. So the area of the rectangle formed by these 2 points is going to be the base or the width of the rectangle, which is 3 minus 0. 3 minus 0 is obviously 3, times the height, and the height is to be taken off the left-hand point, which is 100. So this is 3 times 100. Plus, likewise, 7 minus 3, guys, is 4. 4 times the height is 85, of course. 85 is over here. And finally, 12 minus 7 is 5, multiplied with the height at 5, which is 69 over here. So let me just grab my calculator. It's 300 plus 4 times 85 plus 5 times 69, which is 985. 985. What is the unit? Units are again really important. This is just the area under the curve, right? This is just the area under the curve. So the integration of C with respect to T is just going to be the multiplication of the unit of C versus time. Although I don't think so they have asked this anywhere. Yeah, it doesn't make any sense. I mean, we can write the unit. There's nothing wrong with writing degrees Celsius times minutes. But what will make more sense is when we'll interpret the meaning of 1 over 12, integration from 0 to 12. So anyway, the Riemann sum is this. But what is the meaning of 1/12 of this one? Well, this looks like the average value of the function, right? Because the average value, let me just make some space over here. Okay. Otherwise, I'm just gonna make some space here. And the average value of the function is actually something which looks like that, because we know that the average value of the function is given by integration from a to b of that function fx dx over b minus a. So that's what it looks like over here. Integration from 0 to 12 of ft dt over 12 minus 0. That's going to be the average value of the function, and that's where this 1/12 is coming from. So if they're asking us to interpret the meaning of 1/12 of this, so let's first divide 985 by 12. 985 over 12, guys, comes out as 82.083. So 82.083 degrees Celsius, and this will just be degrees Celsius. And the meaning of this is the average temperature of the coffee in the cup from 0 to 12 minutes is 82.083 degrees Celsius. This is how we are gonna interpret the meaning of this answer. I hope this makes sense. Let's go to question number C, part C. For 12 to 20, the rate of change of the temperature of the coffee is modeled by C prime T is da 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 da, where C prime is this. What is the temperature of the coffee at T equal to 20? Show the setup of your calculation. All right. So obviously we have to find the antiderivative of it, and we have to use a calculator as well. But we need a point, a reference point, right? If we go back, they have actually already given us the value of temperature at 12 minutes, which is 55 degrees Celsius. So I'm going to borrow that as the initial number because I know that at T equal to 12, the temperature C of T is 55. What is 55? Yeah, 55. So I'm going to say that the integration of, or the antiderivative of C prime T dt from, I would say 12 to 20, 12 to 20 is going to be what? Integration of C prime T is nothing but Ct, right? So this is going to be C of T, and we put the lower bound 12 and the upper bound 20. This is, I'm just using an FTC here. So that's going to be C of 20 minus C of 12, right? There is no doubt about this because I'm just using FTC. And what is this thing? This thing is just plugging into the calculator, right? So let me make some space here, and just to avoid any confusion, I'm going to rewrite the entire C prime T, which is negative 24.55 over T multiplied with e raised to 0.01 T, and obviously there is a dt over here, which is this. So let me calculate that. So this value. So if we calculate the left side, over here comes out as negative. Let me just check the number real quick. We have 14.6708 is equal to C of 20. And what is C of 12, guys? C of 12, that is the temperature at 12 is 55. So this is 55 over here. I'm just going to add 55 both the sides over here. So if we add 55, the left side becomes 40.329 degrees Celsius. That is equal to C20. So which means that the temperature at 20 minutes is 40.329 degrees Celsius. That is the answer to this question. The last question. Now we are given that the C double prime T is this thing from 12 to 20. Determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate, and give a reason for your answer. Okay, so I think we can graph this because they are asking whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. So the temperature of the coffee is definitely decreasing, but they are asking about the concavity, right? So for the concavity, I think I need to graph this particular function, which is the double prime. So let's do that. So if we graph this, the graph looks something like this of the above function. And as we can see that C double prime is positive, right? It is above the x-axis. So since this is above the x-axis, that's going to be concave up, and concave up function is at an increasing rate. The rate of the concavity, that's the meaning of concavity, right? If it's concave up, that is at an increasing rate. If it is concave down, that is at a decreasing rate. This is what we had for this question. I hope this makes sense. Let me know your thoughts in the comment section. I'll see you in the next video. Bye-bye.